So I found a really nice parametric differentiation and integration question. You probably wouldn't have seen it before because it's from the international spec, but it's a really big question. It's 17 marks, and that means that I can't really go through the whole question in one video because it would just be too long. So I decided to split it into parts A and B for this video, and then very soon I'll upload parts C and D. So pause the video, have a go. You've got the question here, and see how you do. Okay, so let's just read the question and just understand what's going on. So figure 6 shows a sketch of the curve C with parametric equations x equals 8 cos cubed theta and y equals 6 sine squared theta. Let's not worry about the limits for now. Given that point P lies on C and has a parameter of theta equals pi over 3, find the coordinates of P. So it's only 2 marks. It's very, very easy. All you need to do is just sub this value of theta into 6 sine squared theta and 8 cos cubed theta. So if you do that, this is what I've written. So how I like to write it is, instead of writing it exactly like it is in the question, I like to put brackets in and then put the cube on the outside just to make it that bit easier. So once you kind of compute that into your calculator, you get really nice round values of 1, and then you also get 9 over 2 for x and y. So remember, when you're asked to write the coordinates of anything, you have to write it in this form, otherwise you might not get the mark. That's really important, don't forget that. So the second part of this question is now parametric differentiation, and it's to do with normals. So when you see normal, you should instantly think, okay, whenever I get the gradient and I plug in my value of theta or whatever it is, I need to do the negative reciprocal of that to find the gradient of the normal rather than the tangent. So always keep that in the back of your mind, and even if you want to, you can write that down as well somewhere. So how do we do parametric differentiation? Well, you can use this formula. So dy over dx is equal to dy over dt over dx over dt. So you basically differentiate your y, you differentiate your x, and then you set y over x. So I've written x here, which is 8 cos theta all cubed, and I like to write it like this because it makes the chain rule a lot easier to compute, and you'll see what I mean when I go through it. So x is that, and then dx over dt. So how I got this is by first multiplying the 3 to the 8 to get 24, and then you have cos theta in the brackets, and then you take a power of 1 down, so you minus 1 from the 3 to get 2, and then you times this whole thing by the differential of the bracket. So the differential of cos theta is minus sine theta, and then you can rewrite this as minus 24 sine theta cos squared theta. Now this should be really easy for you if you've revised differentiation. So if that's a bit difficult for you, make sure you're doing a lot of practice on the chain rule for differentiation. So the same thing with y. This is slightly easier, I think. So the first thing you do is you times the 2 down to the 6 to the coefficient, which gets you 12 sine theta, and then you times whatever's inside the bracket by its differential. So you times this whole thing by the differential of sine theta because it's in the bracket, and you get cos theta. So you end up with 12 sine theta cos theta. So those are your two differentials for each x and y, and then you could just plug your differentials into this to get your final answer. So you do y, dy over dt over dx over dt to get this, so this thing here, and then you can cancel out one of the causes and then both the sines as well to end up with this function here. Now some people would also write this as minus 1 over 2 sec theta, but I just don't think it's worth it because you don't need to write it in that form. It's not required, and it can just confuse you even more. You're more likely to make a mistake. I would rather just sub that directly into my calculator, the value of theta. So once we've got our differential, the next thing to do is to plug the value of theta into the differential, and we've got the information here that point P lies on C where theta equals pi over 3. So all we need to do is sub in pi over 3 into our dy over dx. So when we do that, all we get is minus 1, nice and easy. But now don't forget, so coming back to the thing I said about the normal, when the question asks you to find the equation of a normal, you always do the negative reciprocal of the gradient. So here, for example, it's minus 1. So the negative reciprocal, what that means is you basically flip the gradient, and then you take the negative of that after flipping. So with this, if you flip it, you don't get anything, you just get -1 again, right? It doesn't change. But because you need to apply the negative reciprocal, this changes to a positive instead of a -1. So I'll give you another example quickly. If I have -4/9, the negative reciprocal, we'd first flip it to get -9/4, and then we'd take the positive of that because we're doing the negative reciprocal, and two negatives make a positive. So this would just be 9/4. That's just a quick example, but make sure you remember to do that. So now we have the gradient of the normal, and remembering from part A, we've also got the the coordinates of P. So now all we need to do is sub each of these values into y minus y1 equals mx minus x1. And I much prefer to use this rather than y equals mx plus c. It's just something that I've always used, and I think it's just a lot cleaner, and you're less likely to make mistakes, but it's preference at the end of the day. So our y value for P was 9/2, and our x value was 1. So we've got our gradient here, remembering this is the gradient for the normal, not the tangent. And then we can just kind of expand that and simplify to get y equals x plus 3/5, which is what is required here. And remember, if you get y equals x plus 7/2, which of course is the same thing as y equals x plus 3.5, I would still say to rewrite it in the form that is given in the question, so in the decimal form in this case, rather than the fraction, just to really show that that is what we got. So I hope you found that useful. I will be uploading the part C and D very, very soon, so stay tuned for that. So also make sure you like, comment, follow, share, and also DM me if you want me to tutor you for either maths, biology, or chemistry.